So what I've got here is the basics of creating a card game in Scratch. It's the very basic skeleton of a card game. And in card games, in general, cards can either exist in your deck. Let's say this deck has 9 different kind of cards and one of each right now. And it allows for duplicates also, so you can have multiples of the same card too, but right now the numbers are just one of each. And then a card can exist in your deck or in your hand and then it's not in the deck, it's pulled into your hand, and once it's played and not shuffled back in the deck, it goes to a third place, which I call the graveyard from Magic, but this is something that exists in poker and many other games too. So these are 9 different kind of cards. They could have like maybe a point value from 1 to 9, or maybe they are cards that give you like attack that deals damage for 2, or heals for 2, or shields for 2, or maybe something that allows you to draw 2 cards, or strikes for 1 damage but has a 50% chance of poisoning the enemy, something like that. When you draw a card, what happens? When you draw a card, it goes from your deck to your hand, and the card you get would have to have an equal probability of appearing compared to any other card in the deck. And that's what I kind of programmed here. Using math. I've programmed it here. So let's draw a card, and I hit D to draw in my code. So it actually hit number 1. So the card type number 1 got activated because that was the highest in these slots, and then this one got a -1 and this one got a +1. So the variables have changed. And now what you would like to have is maybe you cast a spell. Maybe, let's say these are spells, different kind of spells, and you would like to have a piece of code that allows you to hit, let's say, number 1 on your keyboard. And then it checks if you have any ones in hand, and when you hit number 1, then it casts the spell. If there's any more than 1 or more, like any more than 0 in your hand, it would allow you to do this. And then you could program some fantastic effect. And Scratch allows to have many effects. And I don't really want to go into the depths of the, the fantasy of this, because the idea is to show you how the code works on a higher level, and then go to the details of it to see what's going on in the code, in the actual code. So let's say we want to draw another card. This is important. It skips the first now. So let's draw a card. It gets a random value from 1 to the total amount of cards left. And then let's say we get a 6. It counts. You have 1, 2, 3, 4, 5, 6 cards left in the deck. So the kind of card you get is the number 7. Once a spell is cast or an effect is resolved, it goes to the graveyard. So it goes to this third place. And I've just hit a key to move all of the cards to the graveyard. And this is important too, because you don't want to have any cards that you've already used in your hand. So now they're in a different place. So if something checks for a card here, it no longer shows up. And you don't get any infinite abilities. And then let's say that the game is finished. And what happens then? Well, all cards in your graveyard and in your hand, all cards in your hand get moved here, and then all cards in your graveyard get moved here. So that's the kind of reset that happens. I've also added a button that asks. It simply asks how many of each card type are in the deck. So you could use you could create a predetermined deck that you give to your player to start, or you could allow the player to just simply have all the power in the world to create their kind of deck from the pieces that you've built. But let's say if there was like maybe one of these, maybe two of those, five of these, a couple of those, and just everything else is, I guess, one. Maybe one's a zero. There's none of those in the deck yet. And then let's say the ninth card is something super important, like maybe a resource or mana or something. Then it goes, maybe we have 30 of those. So now this has a very high probability of being drawn, and it is much more likely to be drawn than, let's say, that card number one. So we draw, when we draw our starting hand, let's say it's 5 cards, 1, 2, 3, 4, 5. We got 4 of these number 9 cards, and then one very special number 2 card, number 2 kind of card. So that's important to me. Like, I really like having multiples of the same kind of card, and this code can also be extended. You could have unique cards if that's the kind of card game that you have designed. You could have, let's say, maybe like 15 different cards, unique cards. And what you would like to program is something that checks to see if a card is in your hand. So when you hit a key, maybe it checks, or clicks something on the screen, it checks if you have it in hand. If you don't, nothing happens. But if you have it, then a wonderful effect that you have created happens. So what this guide is not, it's not how to program your card game, not your specific card game. So you will have to use your own knowledge and creativity to make your exact thing that you have in mind. But what I have created is a skeleton that allows to create the creation of many kinds of card games. And you could make something that like I use plenty of variables, maybe counting card totals. So adding all these together gives you how many cards there are in the deck. That's pretty basic. So this is just a placeholder for this demonstration, but what happens when a card is played is basically you trigger something. For me, it's right now the right arrow, and then it will work until you have 0 of those cards in your hand. What happens is you change the hand size by -1 and add 1 to the graveyard. And in between these lines of code, you could put the wonderful effects that you have created by yourself. Also, this is what the reset looks like. It's very similar. It takes any cards that are left in the graveyard and moves them back to your deck. And I do this all at once. Obviously, you would not want to play your entire hand all at once, like I showed just now, but you would maybe cut these into, tap that and move it and give it a new starting trigger, which launches the effect. But this just basically resets the graveyard. It's very simple. It repeats, and it's extendable. What you would do if you had more cards, you would simply add one of these blocks. I've programmed it so that when the D key is pressed, it broadcasts draw, and when I receive draw, this is what happens. First of all, it has to forget any previous numbers that it has received, so I want it to set to 0. Then I want it to pick a random number from 1 to the remaining cards in the deck, which is the total of these. Then I want it to think draw roll. Well, that's just for this demonstration. I show it on this, but you could definitely hide this. You wouldn't need, maybe this is something that happens under the hood. So then if draw roll is 0, then I want it to stop this script. And some games do this differently. When there are 0 cards in the deck, then maybe the character loses the game or something like that. Maybe something more dramatic happens. Or maybe when the draw roll is 0, that's possibly when you shuffle the graveyard here and draw a new card. You could extend this, but this is how I made it happen. Because it was getting a minus value, which I thought was ridiculous. You know, it pulled one card from here and added it here, and then it stopped working. So I made it so that once 0 is hit, then there's no problem because the script stops. So one thing that I have not touched is how long it would take to code something like this. Maybe an afternoon, and then adding new cards would be just some minutes or so. And what happens here is drawing has to be described in this fantastic way because I want it to respect my decision to draw from a probability pool. So if I roll something that is smaller than the total number of these cards or the exact amount of these cards, and also it's not more than the full number of these cards, then something wonderful happens. We draw the one of these cards, it gets a -1, and this cards in hand gets a +1, and we stop. But if the draw roll, which is once again a randomly selected number from 1 to the total number of cards in the deck, not the kinds of cards in the deck, the total number of cards in the deck. If that is more than we have here, and also it's not more than these two combined, then something wonderful can happen. So I've described this exact area in the code. I've described this exact area. So it's something that is more than 1, but not more than 1 and 2 combined. So what's left is the exactly every card here. And this goes on and on. This goes on and on. What basically happens here is you get something that can be very easily extended, because in the next part I describe something that's more than these two combined, but not more than these three combined, you know. I want to give you a slow scroll of cards 2 and 3. So this is the second piece in here, and this is the third piece in here. So you can maybe just have a look at those and see what's going on here. What's different between these second and third is that I've added a variable with a name 2 total, 2 in hand, 3 total, 3 in hand. And also the values that it checks have to grow. So you add just number 1, it has to be bigger, 2 has to be bigger than 1, and 3 has to be bigger than 1 and 2 combined. But also you must not go too far. It it cannot be greater than 1 and 2 combined, and 3 cannot be greater than 1, 2, and 3 combined. So you just add these +1s, +1s, +1s. It's right here in the operators. So you just very simply give it a +1. You will see even if we scroll all the way down, it's not very complex. It's simply 1, 2, 3, 4, 5, 6, 7, 8. It goes up to 8, and then it realizes that you must not go over. It also, so it's not allowed to take any rolls that are larger than all of these combined. It would not actually produce those kind of rolls, but I like my code to be extendable, so even the last one, even the last piece in here has that reminder, just so it's more easy to extend if I want to. So here's something that's maybe interesting to you, or maybe something that you want to have in your code. This is the deck builder tool that I chose to use for this demonstration. And once again, it works if you want to have a preset deck. You just don't let the player have this available. You can just adjust these numbers and forget about it, hide it. But if you want the player to be able to like make their own kind of deck, then simply ask, how many cards would you like? How many of these variables? What's the value of these variables? So it goes through each and every one of these, and once it gets to the end, it just stops. So yeah, that's just what I've made, and I think I'll use this. I think I'm pretty much done here. I know it's not a gameplay example, but you have to understand that I want to show you the skeleton, the basics, the core of what happens inside a card game. So yeah, that's pretty much all I can say. I don't know. Yeah, once you understand the code that I just showed, I think drawing cards is most complex. I think it's the most complex part of this. But I think I've solved it pretty elegantly, if I can say so. So because I've been pretty abstract and math about this, I want to make a bear. This bear is our card game character. It's the best bear ever, and it loves the number 9 card, which is the bite card. And this is how I programmed the bite card. So the bear uses the cards when it's clicked, and this is what happens when it's clicked. You could change this, it could be whatever you want. But it checks, importantly, it checks to see if there are card 9s in your hand, and there are. And then it changes that number by -1 and moves 1 to the graveyard. This is important, it's how card games work. And then the bear says roar, and then it bites. It changes the enemy health by -2, and also something interesting happened, which is just a flourish that I programmed. I wanted to draw 1 or 2 cards. You don't know how many cards you get. You could get 1, at least 1, but you could get 2. So let's see if this works. Let's see if this works. I try really hard to poke the bear.